Alright guys, we're going to be looking at a parallelogram problem, but this time slightly higher level of application. Before, in the previous video, we checked out very basic level solving for missing angles and missing sides. Now we're going to be looking at solving using expressions. We're going to be solving using expressions. Now, you guys can see here, the first thing we want to look at when we're approaching these problems is that we are using a parallelogram. So that means we can apply all of the properties of a parallelogram. We use all their properties. So, what we're going to be doing, first thing we're asked to find, says find the length of CD. Find the length of CD. So it's this length right here. What other length has the same measure as CD? It's BA, right? We know, because it's a parallelogram, that opposite sides are going to be congruent to one another. So it's very easy to see. We can follow along that 5y minus 1 equals 2y plus 8, because opposite sides are congruent to one another. Same thing with BC and AD. Notice I'm using the little dashes to mark congruency. I mean, the BC and AD don't really have much to do with what I'm asked to find, but it's still duly noted. So we need to solve for y. You guys know we got to get all the y's to one side, all of our constants to the other. So I'm going to subtract 2y. We get 3y minus 1 equals 8. Add 1 to each side to get the numbers to the other side. And we get 3y equals 9. I think it's pretty easy to follow from our next step that y is 3. That is very, very helpful for us. Now I'm going to erase some of this work so we have a little bit more space. All right. So we have right now y equals 3. And we'll use that for our benefit. Now, because it doesn't ask for the value of y, that doesn't mean we don't need it. It asks for the length of CD. The only way we can find the length of CD is by solving for y. And if we know that y equals 3, again, the whole reason why we went through that last process is so we can plug it in for CD. And it's 2 times 3 plus 8. So this would be 6 plus 8. And we should get that CD equals 14. A nice way to check this would be plugging it into AB as well, because if we did it properly, it should also be the same. 5 times 3 minus 1, 15 minus 1 equals 14. Looks like we did a good job there. We want both of these sides to be congruent because it's a parallelogram. That's one of our properties. I think that's property 1 of a parallelogram. We all good so far? The viewer says yes. The viewer says yes. All right. So now, I'm going to erase this. If you need to, you can pause and get down some of this information. I'm just going to move forward and start looking at the next portion of this problem. All right. So now, portion number 2 of this problem. Here, I'll even leave the answer up. Let's move it, actually. Ta-da. Now, the next portion says we need to find the measure of angle C. Measure of angle C. Now, sadly, you'll notice that they did not give us an expression for angle C. But what's nice about a parallelogram is if you know one angle, you can figure out all angles based on properties 2 and 3 of a parallelogram. So, let's at least figure out what angle A and angle B are. We can fill that in. What type of angles do we have with angle A, given angle A and angle B? Yes. They're supplementary because they're consecutive. Angle A plus angle B will equal 180. We know that angles that are right next to one another, just like was previously stated, are supplementary. So let's substitute in. We have 16x minus 4 plus 14x plus 34 equals 180. Sorry, I know I'm trying to squeeze this all in, but you guys can follow along with the work. So let's look at our like terms and combine them, because we want to simplify first. This would simplify to our 2 x's, 30x. 34 minus 4 would be plus 30 equals 180. We have a nice linear equation now. Very easy to solve. Let's continue our equation over here. If we're solving 30x minus 30 equals 180. We already have our x's on one side. We obviously want to move the constants to the other. We add 30 to both sides, plus 30. Oh, sorry, this is plus 30. So we want to subtract 30 from each side. My apologies. Subtract 30 from both sides. And we get 30x equals 150. Very easy to isolate x here. I think most of my viewers know how to do this now. And we get x equals 5, if I'm not mistaken, right? Good. Those cancel out. Goes in 5 times. Perfect. Now, again, it did not ask for x, but we can use it. Because we know if we can use x to find the measure of one of these angles very, very easily. If I plug in x into this equation, I will get 14 times 5 plus 34. Can someone plug that in their calculator for me real quick? Yes, go ahead. Yeah, what angle A is. It's 104. We get A is 104 degrees. So we can use this answer to fill in all of our other angles. If A is 104, what's B going to be? 76, because they have to, again, be supplementary. What's angle C going to be? It's going to be 104 as well, right? Opposites are the same. Angle D, also 76. That's why I really like this problem, because it illustrates not 1, not 2, but 3 of the properties of parallelograms. The only one we did not touch on is the diagonals, but we can spend a little more time looking at that in another video. We can probably post some other questions. I'll try and get some other questions up here shortly. I just wanted you guys to get an opportunity to see how we could apply parallelograms and use the properties of algebra in order to solve equations. All right, it's just a nice general review for solving linear equations. All right, make sure you guys check out my next video, which will probably be on rectangles and rhombuses. I want to give a shout out to B1 for sitting in this class. Hey, there we go. This is filmed in front of a... Do not follow Lindsay on Instagram. Thank you guys. Check out my next video.